So a few days ago, Wahoo released a firmware update for their 2018 Kickr and Kickr Core smart trainers. This firmware update provides multiple Bluetooth connections and cadence detection and reporting from the Kickr itself. The main feature, or the main reason why the cadence thing is really important, is because for devices like the Apple TV, which are limited to a very low number of Bluetooth connections, this makes it possible to use the Kickr and have it report cadence with a heart rate sensor and all of that without having to use a companion, like the ZWIFT companion device, to report or to manage the connections with the Apple TV. Not to say you probably won't still use the companion. It just makes it a little bit more reliable because there's fewer moving parts in the system. Here we are updating the firmware. The first time I did this with the Kickr, it wasn't entirely obvious how to do it, and actually had to use an iPhone to do it because it wasn't working with my Android phone. But here now, this is an Android phone. Updating the firmware works really well. So it just takes a couple minutes to do that, and once you're done, you're all set. So to test the accuracy and function of the Kickr's new cadence detection feature, I did a ride and matched it against both a Garmin crank-based cadence sensor and a Wahoo cadence sensor that was on my shoe. The general findings are the same between them. There's actually it's similar enough that it probably only makes sense to look at one of them, but I did it for both, and we can see I'm just flipping back and forth between them. But essentially the same thing is true for both. So to make it a little bit easier to see the difference, I only put two of them in the same graph. And what we see is that one, it works pretty well. The average RPM is the same over time, even when you drill into a smaller time frame. But what's particularly interesting is that the Kickr detected cadence is just a little bit. It's a little laggy. It's slower to figure out what the cadence is, and that makes sense because it's running an algorithm to determine what the cadence is instead of just measuring it directly. But you do get a little bit of wonkiness in it. So here you can see where the Kickr detects a value which is wrong. Where the dedicated sensor is a much more just Occam's razor kind of stuff. It's just a sensible flow here. And then it also kind of, as you change cadence very quickly, it misses some of those changes. Now, whether or not this matters depends a lot on what your use case is. If you do a lot of workouts that require that the cadence is highly accurate and you shift cadence rapidly as part of your workout, then this feature may not be very useful to you. But I think for the vast majority of use cases, it's probably good enough because it does get it gets it really close, and it's only when you drill into it very closely that you start to see these differences. So I think it's a welcome change. I mean, a welcome feature, and of course it's free. So the thing that you were using before will continue to work. There's no reason why it won't. So in many ways, it's a free found feature that only adds value if it works for you. That's great. If it doesn't, then you can continue to do the thing that you were doing. So I wanted to show how the new feature works inside of ZWIFT, which is the my training platform of choice. Here we are. I'm going to add a heart rate sensor first, just to make it a little bit easier to see what's going on. and then go ahead and add the kicker, which is you start with the power source, and then it should automatically detect that it is a controllable smart trainer, and then go ahead and select the cadence where it finds it, and then start a ride. Now in this ride, I specifically went out to try and find the limits of the detection algorithm. So I want you to pay attention to the RPM and the power, because watching those two things provides some interesting insight into where it works well and where it doesn't work so well. There's quite a few places where I went from like very low cadence to very high cadence quite rapidly, and you can see there it just kind of fails, where it loses all of the RPM, and then or the power drops all the way down and it's still detecting RPM. So this is one of those things where it works well enough probably, but there are quite a few cases around the edges where it probably doesn't work well enough if very reliable cadence is something that you need to have as part of the way that you're working out. I'm just going to let this play out. There's not a whole lot more that I can add. Just pay attention to the RPMs and the power. It's pretty interesting. If you found this video useful, please like it. If you have any comments or suggestions around this particular feature or other things that are going on with the videos, please leave them in the comments below or hit me up over email. Thanks for watching.